Hello. Okay, this will be a series to learn how to work with Docker, but in a Mac environment. I have some experience with this kind of thing, and I already have Docker installed in my machine, for example, but in this case, the idea is to start from the ground. If you know something about Docker, if you already work with Docker, this is not your series of videos. This video and the next ones are for people who want to start learning Docker from zero. In my case, I'm going to do it everything like it was the first time for me. Will be the first time for you maybe, but anyway, let's start. Okay, what is Docker? As we can see here in this page, this is the official page of Docker. It says develop faster, run anywhere. Docker is a tool to work with machines in a way that is a kind of different respect of virtual machine. Let's say, for example, I'm going to draw some things here. Let's go to this place, is draw.io. I'm going to start with a new diagram just to tell you how this works. Okay, I'm going to work with this kind of thing, and let's say that we have an operating system. In this case, OS could be whatever, Windows, Microsoft, or Mac OS. It doesn't matter. Or let's say, for example, that we have a virtual machine and we have our OS container here. If we are going to work with virtual machines, then we have a virtual machine here. This is a virtual machine, and you have all your environment here, virtual machine. If you don't know what is virtual machine, let's say that we have this small box inside our host operating system. We have different kinds of virtual machines. Let's say, for example, I'm going to check some of them. We have something like Oracle virtual machine. We have VMware is a virtual machine that is common. Another kind of virtual machine it's one of the Microsoft. I don't remember the name right now. This was a virtual machine in Java, I think. It's free. It's one that it's free. Let's see, VirtualBox. That one. I was thinking in that kind of virtual machine. This is a machine, a complete machine that you can install on the top of your operating system, and you can have one. You can have let's say VM here. Sorry, VM. We can have one. We can have two virtual machines. We can have three virtual machines. Every virtual machine is a complete operating system. The thing here is that the resources that you need to run this kind of technology on the top of your operating system is resource demanding. On the other hand, if we work with something like Docker, for example, it's a container. The thing will be kind of different. Let's say this will be a container. Docker, for example, it's one type of container. We have more, but in our case, we are going to focus on this kind of technology. The thing is that if this is your operating system, Docker, and you can have many instances. Sorry, this is new for me. This keyboard. Okay, now we have it. We have multiple instances of Docker on top of your operating system, but the difference is that we are running sharing the resources. We are not installing a complete operating system. We are installing just a container. A container means that we are sharing some things between our host operating system and our container. The main thing here is that we are sharing the permissions. We will see that in the next videos, but for me at least, the most important detail here or difference between a virtual machine and a Docker container is the permissions. When you work with a virtual machine, you have complete control over your permissions. at the disk level. But when we work with containers, we need to share the same set of users between the container and the operating system. Okay, let's start with this thing. What is Docker and how we can install this in Mac? As you can see, if I go to products here, I'm going to work with Docker Personal. That's enough for our purposes. You can sign up here, as I can see, and okay, let's do that. Let's sign for free. I'm not so sure if I already done this before. I'm going to work with my own name and my email. Well, let's choose a password. I'm not a robot. Let's see what happens. This is my email. This mail already exists, as I thought. I already did it. I'm not so sure if I have. I'm gonna try to download, but without signing in. Let's try with Docker download here. Maybe we can have some. It's like this one. Yes, we can download here. This is the link, the direct link, without signing in Docker, into Docker. We can download Docker desktop Intel chip in this case. Well, that's not entirely accurate because we are working right now on an Apple machine, so I'm going to work with Docker for Mac, but in an M1. As you can see here, in my case, I'm working with a Mac OS Monterey on Apple Pro. So that's my machine. Well, it's finishing already. Well, we have it, and all what we need to do is to drag and drop this application into our application folder. I already done that, and I already started the Docker desktop. You are gonna get something like this once you start the application, and you are gonna get a dashboard. In my case, this is the dashboard. Containers, I have nothing, so it's a kind of empty at this moment, and we can start with Docker right now. How? That's the thing. How we can start with a Docker container? If you go to the Docker desk, the Docker documentation, let's see, you will see that docs. You will see that you have a kind of different types of instantiation for containers. We will use, in our case, docker-compose. With docker-compose, you can build a real development environment in your machine. When I say a real development environment, I'm talking about. Just a second, I have a technical issue here. Well, again, I'm going to play this. Yeah, already it's done, solved. I was saying, we need to start with Docker in some way, and this is the documentation to start with a container. And I think what we need to start with a container is to download an image. Docker works with images. We need an image to install inside our machine, and after that, Docker will create a container using that image. For example, Ubuntu images. We have something like Docker Hub. I'm going to get into there. This is the place where you can download a lot of containers already prepared for you to work. In my case, well, we can start with this one. It's a kind of popular one. It's Ubuntu. Let's go to Ubuntu and how we can work with this. With Docker, you need to choose an image, and an image has a tag. You can choose the tag that you would like to work with. with this kind of string. In our case, if we choose, for example, 22.10 or kinetic 2023 0308 or kinetic only, then we are going to work with that kind of image. And how we work with that? If we see here what is this is the definition of what's a container and how we can kind of understand what's a ch root technology, then that's in essence that's what's Docker is. It's a ch environment. It's a kind of customized ch root environment. The file system is simply coming from the image, but the container adds additional isolation, not available with simple use in chroot. That's what I said before about containers mainly. Okay, use use docker compose that we are going to. That's the thing that we are going to use. And here's the thing: use docker compose. We are going to focus on this part of the docs in order to run our Docker installation. The first thing that we can run is this command, docker-compose version. I already have this here. If I'm not so sure what's going to happen if I run this on my root, but anyway, let's do it. Docker-compose version should run. Docker-compose 2.15.1. Okay, perfect, no issues at all. Oh yeah, that's a place that we can work with, but in any case I'm going to move to the dev directory, and here I have a small file that we can start to work with in order to learn how Docker works. Okay, let's do it. bi docker-compose, that's the file that you need to build to create your environment, and it's a kind of easy thing. As you can see here, we have it's a simple YAML file with a specific section, with specific sections. I'm going to tell you what is everything here. The first thing is the version. We are working with the version 3.7, and as far as I know, this is the latest one, so we can use that kind of version to work here. The first section that we have is services. In the service section, we define how many containers we will use in our environment. In this case, I have Ubuntu. That's the name that I'm giving to this container, to this first container. This Ubuntu service will use an image. As you can see, we are using spaces here to organize our content. So image is going under Ubuntu, and in this section we are going to define what I said before. And the thing is, we are going to define the tag that we want to download as image from the Docker Hub. In this case, we are using Ubuntu, and the tag that we want to install is 22.04. That means that we are using this tag 22.04. As easy as that. That's all what we need to do. The container name it's just that. It's a name for your container in your installation. This one, the next one, is kind of important here. With this command, we are going to define the host port linked into the container port. What this means? Here's the thing. When we are working, let's forget about this part now. We already know that we are working with containers, and we're going to move a little bit this. Let's say that we have a container here and another container here. This container here, in our case, the first one is Ubuntu, and the second one will be something like maybe our database. I'm going to say MariaDB for now, MariaDB. So we have in our containers we have ports that should be, let's move here this in order to make this a little bit more clear. We have an operating system here with ports 2, And for example, let's say that we have a port, in this case the port number 80, it's the HTTP port. This port here should be linked to some port on our container side of the equation. So sorry, we need to link this port to some port in our container. In our case, if we write something like this, we are the link that we are going to create will be between the host port. First is the host on the left side, and on the right side is the container port. As you can see, we are linking the port number 80, it's the HTTP port, to the port number 80 in our container, inside our container. How we can do that in our file? We define this kind of thing using the same format. On the left side is the host port, and on the right side is the container port. So now we know that we are linking the port number 80 to the port number 80 on the container side. The same thing for 3. This is the HTTPS port, as you already maybe know. With this port on our host, we are going to link this port, the same number of ports, but in our container. If we do something like, for example, something like this, 8081, let's say 8081, this means that we are going to link the port number 8081 to the port 80 on the Ubuntu side. I think that with this explanation it's more than clear how this works. So let's back here and let's go to the next part, volumes. This is a kind of interesting part. With this kind of volume, in this case we are talking about shared volumes, we are making something similar that we already did with the ports part. We are linking two things. One thing on the side of the host, in this case our host file system, how we are going to link that part to be visible from inside our container. What we are saying here? We are saying here that this path, users kublai dev ubuntu www, will be visible from the container side in this path var www. That's the thing. That's all what we are doing here. We are sharing a file system, making that part of our host disk visible from inside our container. We are going to check this in a second. This is just a comment. You can use you can define as many volumes as you want for your container. In this case, we are defining only this one, and we are going to remove these other two. The third part that we're going to use, the first was ports, the second part was volumes. This third part is networks. We are going to define a network for our containers. The thing here is that when we are working with Docker, you have your own network. What this means? This means something like this. Let's move this like that. Let's say that, for example, we have our MariaDB container here. What I'm trying to tell you now is that we have we can move this outside of our view and move this down. Let's see, something like this. We have this and we have this too. We have a kind of another, not sure, I don't want to fill this, and I'm going to put this kind of line. We have a network to connect our machines. It's a virtual network that we need to define in order to communicate our machines inside our system. I mean, we are working with a virtual machine to build a network that will be able to create communication between our machines. Something like this. Our machines will be able to run packets between each other using this kind of network. Let's move this just a little. So in this context, we are building a network that will be able to run packets, TCP/IP packets between our containers. But more than that, this kind of network will enable us to communicate between our host with our host, but with a kind of minor details here. This is the main architecture that we are going to work defining a network. We are defining a network. In our case, our network will be named like ByteBoxNet. That's the name of our network. And inside that network, we are defining an IP address for our container. In this case, I'm defining this address 20.0.0.2. That will be the address of our container inside our in our environment. In this case, for example, this one. Let's move this a little. This will be .0.0.2. That will be the address of that container in our network. That's the thing. Let's check the second part. RabbitMQ. That's another thing. It's another container that we can use. Maybe it will be useful in some other video. It's a queue system in order to communicate information between microservices. We can discuss about that in posterior sessions. But as you can see, the structure is almost the same. We have a host name in this case, an image that we want to download from Docker Hub, and a tag. That's the thing. That's the definition of the image and the detail of the image, the kind of image, the subversion of the image that we want to use. A container name, the ports that we want to share between the host and the container, and the volumes. And we are not talking here about shared volumes like we did in the case before. We are talking about Docker volumes here. A Docker volume is a part of your host disk that Docker will use as own. Docker will build the volume and will perform all the things that internally it needs to do in order to work with that part of your disk. But you will not be able to check the content of that volume from your host. That's only for Docker. From a performance point of view, it's better to work with this kind of volumes if you are going to work with, let's say, databases inside your database, or in this case, data for your queue system. The last part, networks, almost the same as the last one. We have the network name, and we have to define an IP address. In this case, 20.0.0.3. Okay, and the last one, maybe this is the last one, MariaDB. We're going to check this one more, and after that we're going to run this configuration for you to see what's happening here. In this case, MariaDB, we have the image is MariaDB in English, 10.11. Restart always. That means that if for some reason this container hangs or is terminated, but for any kind of reason, it could be an error, it could be a shutdown, it could be whatever, then the container will restart again. Not questions asked, just restart in order to maintain the service. This is container name, as we already saw in previous cases, and this section is kind of new here, is the environment section. In this case, with MariaDB, we can define some environment variables inside the container that will be used for MariaDB as parameters. In this case, we have 4 environment variables. MySQL database is the name of the database that we want to define in our container. Inside our container, MySQL user is the user that we want to use. MySQL password is the password that will be used for this user, and the MySQL root password and that's the root pass. I mean, it's the root pass for the root in this database server. As usual, the port for MySQL, in this case MariaDB, is the same as you know, will be 3306. That's the default port for MySQL and MariaDB too, of course. In the volume section, as we did with the other container, here we are using a volume created inside Docker, will be managed by Docker, and will be available in this path inside the container, var leave MySQL. And in the network section, maybe that's the last section of this definition for MariaDB will be, as in other cases, the networks part with byteboxnet as the name of the network and IP address 20.0.0.4. Jenkins is the last part of this. The definition is the same. I think that's enough for now. And in the network section, then we can define specifically the network. We are telling here first of all the name, and in IPAM section we need just one line. It's the config line. The config line will define the subnet, I mean the part and the section of IPs that we want to use in this network. As you can see, in these networks for MariaDB, Rabbit, and Ubuntu, we are using 20 as the first segment of our IP, and in bytebox we are using that one exactly 20.0.0.0. That means that we are going to use this segment of IP addresses for that network. In just to create a different one, in this example I used in Jenkins another segment. It's 40 and the address 10. So I defined two networks. That means that you can define any number of networks as much as you want. In this case I'm using Jenkins with the subnet 40 and byteboxnet with the subnet 20. That's for the networks. And in the last part we are going to define our volumes. In this case we have one volume main that is external. That's why it's true here. We're going to check this what this means after, but for now it's enough to say that we have an external volume, and we are defining some other ones: MySQL DB, RabbitMQ data, RabbitMQ log, Jenkins data, and Jenkins Docker sets. We already saw this one where it's used MySQL DB. We are using that one here. As you can see, we are using MySQL DB as a volume here, and it's defined in the volume sections here. So if we go out, everything that we need to do really is this. We need to run a command, docker-compose up, and with that we are creating everything that we need to run our containers. I like to do this because I can see the log here, all the information that I need to check that if everything is going wrong, or if it is going right, sorry. And if something is going wrong, you can check here too. Like in this case, for example, Ubuntu is saying Apache could not reliably determine the servers fully qualified by name. This is an error that it's not relevant for us at this point, but we already know that is happening, and we can check after that how to solve this. For our purposes and to illustrate what's happening here, we can go back to our Docker desktop. And as you can see, we have our containers running here and inside our dev directory. So this is how this is organized. If you have a dev directory, let's say I'm going to show you this here, a new tab. This means that, as you can see here, I am inside the dev directory inside my home directory. If I check this, I'm inside users kubelet dev, and in my dashboard I am seeing that dev this is the directory. Inside that directory, I'm running these 4 containers, and we can check the ports that I'm using here, and that's enough information for me to know that this is working properly. Well, I believe that for now it's enough explanation for this small introductory chapter. Let's see what's happening, what's coming in the next session. Okay, goodbye.